Hello everyone, welcome to the first MTE203 MATLAB session. Since this is an introduction and not a comprehensive MATLAB course, we're just going to look at the most useful and most common features of MATLAB. This video session is developed based on the info session document created by Mike Stokowski at University of Waterloo, and the PDF version document will be uploaded on Learn later. First part, we're going to introduce how to use MATLAB like a calculator. Once you open up MATLAB, you will notice a few things. First, a window is broken into a number of sub-windows. Although this can be further customized, the most common setup has at least the workspace here. In later, we'll have variable names and values shown here. And also the command window. In the first part, we'll mostly focus on this part. And also the current folder. Will show the files and data in your folder. The first part of this unit will be variables in the workspace. The variables in MATLAB can be named anything as long as they start with a letter, and also they contain only letters, numbers, and also underscores. For example, we can define a variable names x equals to 5. I can do x equals to 5 in command window. If I hit enter, we'll show there's a variable x, named x in workspace, which has a value of 5. If I don't want to see the second part of the output, which here in the command window, I can put a semicolon at the end. So I can do x equals to 6, semicolon, and here there will be nothing shown, and also the variable x in the workspace is overridden by the value of 6. And you can do multiple calculations such as plus, minus, and also divide and multiplication in the command window. It's pretty easy. You can try that later. And next, we're going to show you how to use complex numbers. In order to make complex number, MATLAB has a built-in variable called I. To use it, you make a complex number like this. You can do y equals to 3 plus 5 times I. And now you'll have a complex number because the I variable is a built-in variable corresponding to the imaginary part. We can use complex numbers just like regular numbers, and they follow all the rules that you learned in high school. One other thing to note is that the MATLAB variable I can be easily overwritten. For example, you can here in MATLAB you can do I equals to 5. Now the I is a variable you defined as 5 instead of the imaginary part. If you do say y equals to the same thing, y equals to 3 plus 5 times I. Now we look at y, it is 28 instead of a complex number. In order to avoid this, so if you want to use a complex number again, you can create them without a multiplication sign like this. You can do y plus 5i instead of 5 multiplication by I. You can do that, and you'll have y equals to 3 plus 5i as a complex number. Now we move on to matrices and vectors. In order to create a vector or matrices in MATLAB, you can use square brackets to indicate that you want a matrix rather than a single number. Here we can say v equals to here square brackets with 1, 2, and 3. Now by hitting the enter, we'll see there's a variable v in the workspace, and it has a value of 1, 2, 3, which is a vector. So now we just created a 1 times 3 vector, which means it has 1 row and 3 columns, right? You can double click on V. You'll see here it has a variable 1, 2, 3, 1 row and 3 columns. And you'll click the close and return back. And now for this part, this is a 1 row. If we want to use several rows instead, and using only 1 column, we can use semicolons inside the square brackets, do the same thing. We can do not the same thing, something different though. It's a now let's say v2 equals to 1, 2, and 3. This is separated by semicolons, and it was shown as one column, however 3 rows. The vector now is 3 times 1 vector. Now, in order to create something like a 3 times 2 matrix or 2 times 3 matrix, for example, we can combine the thing together. We can do v3 equals to say 1, 2, 3. This is the first row, and semicolon we do 3, 4, 5. This is the second row. And also notice that the columns are exact same thing, did the exact same thing for space. For example, I can delete the columns here, delete this here, and I'll leave the space inside. It all shown as the same thing because here is the first row, 1, 2, 3, the second row, 3, 4, 5. Okay. Notice that if you want to use the mathematical operations in linear algebra, you have to make sure the matrix dimensions or agree with each other. For example, if you're trying to add, say, v3 times plus v2, you'll find that it will return matrix dimensions must agree, because you cannot do that in math. So if you're trying to enforce MATLAB to do that, you will report an error. Instead of just simple linear algebras, you can also do transpose, determinant, dot product, cross product, and inverse in MATLAB. For example, you can do, say, transpose. Say, currently we can print v3 like this, and if you want to find the transpose of v3, you can just directly adding a apostrophe behind v3 here like this, and you will have the transpose of this matrix. And also you can find determinant as det. Say determinant of v3 is it says matrix using determinant. Matrix must be square, so I have to get a square matrix. Say I can do v3 times v3 transpose. This will create a square matrix, and now we'll find the determinant of it. And also you can do the similar things backwards. And also you will find the dot product. Say I can do dot product of v1. Say I can say 1, 2, 3. This is the first vector, and also the second vector is another argument passing into the dot function. I'll say 3, 4, 5, and now we'll create a dot product of it. Also you can do cross product and also inverse. These are, you can consider these are vector functions. And besides linear algebra, there are many times when we want to do something that doesn't fall within the realm of linear algebra's basic operations of matrix and vector addition and multiplication. Typically, we can do the element-wise operations. For example, if I have a vector of student scores, say 1, 2, let's do a little bit better. Score equals to, say, 88, 90, 100, and say 70. This is a score of 4 students. And also we want, so this is their final score, and also we have their midterm score. Say score mid equals to let's say 10, 11, 2, and 0. And we want to add these two together, right? We can or divide these two together. We don't want to do a linear algebra calculation, so we want to do element-wise calculations. We can do a the dot calculation. We can do, say, score dot times score mid. This will do a element-wise product between, say, 88 and 10, 90 and 11, and 102 and 70 with 0. We'll find this out. oh, here is OC and here is CO. So yeah. So here, if you type the variable names wrong, of course you will have something wrong. And here the result is 880, 990, and 200. So this is how the element-wise operation does. And also you'll do element-wise operation with something like, you can do it with divide, right? And you'll notice that 70 divided by 0, here's an infinite, right? And also you can do instead of divide, you can do even further with exponential, right? You'll have something like that. Okay, let's move on to the making equations work and introductory plotting. So for MTE203, later on you'll have projects, and in projects multiple times you'll have to do plotting, and the plotting does have some scores on that. So the most things interesting in MATLAB we need to do is usually plot an equation. Plotting is very rich in MATLAB, and there are many options, types of plots, and methods to use. We'll only focus on basic plotting and some of the options, and we'll leave the rest of the options for you to explore. Before we start plotting, we need something to plot. So let's consider a task plotting with y equals to x squared. Now, usually in the MATLAB perspective, making a vector of equally spaced point called x, raise each element to the power of 2 and store the resulting vectors in a variable called y. It would be astonishing tedious if we had to make a vector x by hand. So in this case, usually we do something like this. Say x equals to from 0 to 100, right? We want to, starting from 0 to 100, and in between what's the step of it, we can do set as 1. So this is a starting point, this is an ending point, and this is a step size. And instead of printing all those, I'll do a semicolon to end it to make sure it won't printing on my screen. So here, if you cancel that, you'll see something like this. So there are columns printing on your screen, and if you don't want that, you can do CLC is clear your screen, and your workspace variables are still here, right? And if you double click X, it will say from 0 to 100, and it says the value is 1 times 101 double, right? And furthermore, you can make a variable y that stores the value of equation x equals y equals to x squared. We can do say y equals to x dot. Here, this is a square, and it is element-wise operation, right? So in this case, I will put a semicolon here, and now I have y. In order to plot, we'll do plot, and now the first argument is the x direction variable, and the second argument is the y direction variable. And now you will find here's a figure getting out with the expected plots. All the values here are the corresponding points. You can use the handles in the figures to manipulate it. You can do the zoom in and zoom out. You can move around with the little hand, and also you can do multiple things. You can say insert X label, Y label. You can do it by clicking here X label. You'll see this is the X label, and you can also insert a legend here. You also indicating that this blue curve is x squared. Okay, x squared, and instead of doing that by clicking around with the manual, you can do that by using the commands as well. You can do title, because typically we want to you have the titles and also x-axis and y-axis in your report. So we'll do title. This is my first draft, And now it was shown here in my first draft. And similarly, we can do X label and Y label. I already created a X label in my plot. I can do Y label. This is the string. This is my Y axis. Okay. And if you switch back, you'll see here's the Y axis here. And another thing is we can do multiple plot in a single figure. For example, now you have already plotted y equals to x squared. If you want to plot another one on the same figure, you can do hold on. So this will not refreshing your data. You can do, let's say y1 equals to x, or x plus 2. So this is a line. This is a straight line on the window. And you can create an array. This is y1, 1 times 1, 1 dimension. And now, since you already have a hold on, you can do plot again with x as the x direction variable, and y here is y1, right? And you can specify the color or the line type within that plot. You can do this indicating the red line. Here, this is indicating a blue line. Here, this K indicating a black line. We'll do red line, and also you can do a dash line like this. Okay. Now let's switch back. We'll find, oh, here, this red line is our dash line, right? If we going forward here, this is x, and now the value of it is just a 2, because y1 is equals to x plus 2, right? X plus 2. Other than the standard plotting, you can also do multiple calculations in MATLAB, such as sine, cosine functions. You can do sine functions like this, sine, say sine 3, sine 2. It will return a value, and also you can do cosine and arctangent, arccosine as well. You can also do exponential and natural logarithm. You can do hyperbolic functions such as cos h, here is 2, and also you can do, say, log 2.7. Oh, here is multiple point, here's 2.7 equals to 0.99, okay? And also you can do basic statistics like mean, variance, standard deviation, and max and mean. You can find that in your PDF documentation. Furthermore, if you have anything such as any function you're trying to have, you wish to have, but you don't know what's the name of it. For example, if I want to have rounding or ceiling or take the floor of the number, I don't know what exact the function is. You can always Google it. You can just type, say, floor MATLAB, and in Google you'll find that out, right? And also you can have the document. For example, even though you find floor, you know that this floor thing does the take the x down to the nearest integer, but you don't know how exactly does that work. You can always do help and floor. This will help you to open up the MATLAB documents, and you have some nice noticing and nice explanation of that. And also you will find other related functions such as cell, fix, and round, right? Let's move on to the next part. The next part is using MATLAB as a programming language. In order to using MATLAB as a programming language, you can use here the editor, right? The editor will create an M file as a basis of MATLAB programming without the command line here. Because before we're using command line window to directly interacting with the MATLAB. And now we can write multiple shell commands in a single M file as execution script. So for example, you can create multiples by hitting the tab here, and now we'll just close those. And here in this untitled, I haven't saved that yet. I can first create t. Suppose I have a time from -10. Oh no, so 0 with step 0, 0.1 to 10. So I'm interested in the period like that. And also I will have a signal y. Now the signal y is cosine t. Cosine as a function t, right? And later on we'll have to plot this thing. Plot, now this is t, this is y. Okay, now this is my MATLAB file. I haven't saved that yet. I can do in the editor tab. Here's multiple tab in the window. You can explore it by yourself. It's pretty self-explanatory. You'll hit save. Now it's in your path setting here, so I can save that as cosine plot. Okay, so now this is my cosine plot m. You'll see here in my current folder I have a cosine plot m file here, and I can always run it by typing my file name as cosine plot, and it should getting out. I think I need to close the figure first, and then now let's try that again. I'll have figure 1 like that. The previous reason it hasn't shown up properly because I have my figure 1 opened up and the figure is plotting on that original figure, right? So if I can do that small thing again, I can do figure, this is 2. I can always initiate the figure like that, and can do clear all the variables, and I can run that again. Boom, here it is. Also notice that in MATLAB you can always write logic such as if, else if statement to do the branching for programming constructs. For example, the if statement you can always do like this. I can close that, say q equals to 100, and I'll do if q greater than 10. Now let's make q equals to 10. Here is end. So typically we'll notice that the if always pair with an end, and when you run it, you'll find that the q now value is 10 because it runs all the lines here. Furthermore, we can do loops in MATLAB as well. For and while loops are very useful when you can do element-wise operations. For example, you can say, let's do q equals to 0, and now for j equals to 1 to 10, we can do q equals to q plus j, and hit end. This is a for loop. That is to say, from j equals to 1 to 10, at every time we'll hit q equals to q itself plus the j, right? And if we do that, we'll find that the q now is equals to 55. Although it here prints 10 is because I didn't put a semicolon here, and the variable here, the actual value of q is 55 though, right? If I can do q here, then it will print q equals to 55. And similarly with while loop, you can do something very similar. Say while q smaller than 10 and q equals to q plus 1 and end. So this is a while loop semantics. And the next part is defining your own functions. With the M files, if statements and while loops and for loops, you can already write some programs based on MATLAB. However, these are just scripts. Instead of the scripts, you can always write your own customized functions. A function takes input arguments and return output arguments. It's very similar to any other languages such as Python and C. So, for example, let's create a function called function, say, add. Okay, let's just function add numbers. Okay. So if we're trying to put a function add numbers, we'll have the variables, right? The input arguments is inside the brackets. We'll have the variables x and y. So let's just add two numbers. So this function is a function called add two numbers, and its output is put into the square brackets. So the the typical form of a function definition is you have a output brackets, is the square brackets, inside is the output. So output is out. Because typically adding two numbers while generating one number, right? Let's do that, sum out. And add two numbers, this is a function. I can change names to numbers. This will be more better with the camel case. And inside the function, you can specify what exact the return is, right? You will do sum out. This will be your return. It goes to x plus y. Okay. Sum out equals to x plus y. And now noticing that you need to make sure your m function is the same with your function name. So here it already shown, noticing us that function name add two numbers known to MATLAB by its file name cosplot. So this is wrong, right? So we want to have the same name. We can do rename, change the name, and make sure the name is the same. Now we can run that, and here is not enough input arguments because we create a function, of course, but we can use our already defined function as add two numbers, let's say 3 and 5. Not enough input arguments. Oh, here I added 3 plus 5. This is definitely wrong, right? So I can do 3 and 5. This is 2 arguments, and I'll return 8. So that will be it. And there are a lot more additional notings on that SOE MATLAB info session PDF. And this is our first MATLAB info session. I hope that you have gained some confidence in MATLAB and are ready to explore it on your own in later MATLAB course projects.